function of the sine when we change the amplitude and the period. So what if our amplitude is 2 times the sine of 1/4 x? What does this mean? Well, the 2, this number up here, and as we looked at in previous videos, affects the amplitude. So if I set my graph up right here, here's my y-axis and here's my x-axis, I know that the amplitude of this sine function is going to go up to 2 and down to 2, right? So here's 1, here's 2, -1, -2. And this just means that if I draw these little bounds right here as my guidelines, let's pretend that fits, right? That this goes to 2, right, up to 2 and down to 2. Okay, so the sine function is never going to cross these lines right here. That's the amplitude. The next part is to deal with the coefficient. Well, how do we deal with that? Well, if the coefficient was 1, the period of this function, the period, how often it repeats, would be 2 pi, and that's when the coefficient is 1. So what does it mean if the coefficient is 1/4? Well, it means it's going to take 4 times longer to complete itself, right? So to go all the way up to 8 pi. And there's a formula to deal with this, and we might explain it more in other videos, but the coefficient, right, to get the coefficient, you take 2 pi over the period, and that equals the coefficient. The coefficient, again, is just the number that we're multiplying x by. So this formula tells us that if I want to know what that coefficient is over here, I can think of this formula. Well, I already know my coefficient is, so really I can solve for the period, for p. So if I have 2 pi over p, a lot of these colors are hard to read. If I have 2 pi over p, I know that that equals 1/4. So the period, multiply both sides by 4 and by p, the period is going to be 8 pi equals p. That's the period. And again, the period is how long it takes the function to actually repeat itself. So here I can put some key points. I have pi over 2, well, pi over 2, and then pi, 3 pi over 2, 2 pi. And this keeps going, right? So here we have 2 pi, and then we have 3 pi, and then 4 pi, and then I keep going. 5 pi, 6 pi, 7 pi, and wow, 8 pi over here. If we can even see that, 8 pi. So it's going to take all this distance to actually complete itself. And here, and every other hop we have 1 more pi. So how do we deal with this? Well, the sine at 0, if I plug 0 into this function, it's 2 times the sine of 1/4 times 0, and that's just 2 times the sine of 0, right? 1/4 times 0 is 0, and 2 times that is, well, sine of 0 is 0, 2 times 0 is 0, so it's still going to be at 0, and then at 8 pi, all the way over here, is the end of the function, the end of the sine function. So what I'm going to do is just kind of sketch this function out to get a sense of what it will look like. So what's going to happen is it's going to go up. This is going to be hard to draw, but I'm going to estimate it. It's going to come down. Right, at 4 pi, so this is important. So I know it's going to cross, again, at 4 pi. Why? Because if I plug 4 pi into this equation right here, I get 1/4 times 4 pi. What does that equal? That equals just pi. And at pi, radian, sine is 0. So I know the sine function is going to cross here at 4 pi. And I'm just sketching it here. It's going to come down and back up. Alright, so this is the period of the function, right? It goes all the way. And I'm just going to go back this way. Pi, 2 pi, I don't have room, 3 pi, 4 pi, this is definitely not a consistent interval, sorry about that, and 5 pi. So anyway, this is going to go down here, and that's a terrible drawing, up to 4 pi, and the graph, I'm running out of room. So that's what it looks like, right? The period of this function, it starts off here and goes all the way to 8 pi. That's a pretty large, or pretty slow, I guess, turning sine wave, right? It takes all this different distance, that's the period, which is 8 pi to complete. With the sine of x, right, the amplitude, or even 2 times the sine of x, what would that look like? 2 times the sine of x. Well, that would start off at 0 again, but the coefficient now is 1, so 2 pi over p would equal 1, and then p would have, the period would equal 2 pi. And I guess that kind of reveals a lot about why this equation works. With the sine of x, right, the period, the cycle, just like in the unit circle, was every 2 pi radians, or 360 degrees. So in order for that to be our reference point, 2 pi over the period would have to equal 1. And that means that the period would have to be 2 pi because, I don't know if you can read it, 2 pi divided by 2 pi would give you a period of 1, right? So then a coefficient of, a coefficient of 1. So 2 pi is the period. When we divide by that, we do get the coefficient of 1, so it fits this idea that we have the sine of x. It fits the unit circle where the cycle is every 2 pi. And what it would look like here is if the amplitude was 2, it would come up, right? Come up, and then down to pi, and then back up, and you can see the period for this wave, the sine of x, is definitely about 1/4 of this period, right? You can see it. This is a period of 2 pi, and it's 4 times smaller than the period of this function. And you can think of that to get some instinct that if this was 1/4, then it takes 4 times longer to repeat. If it was 1/8, it would take even longer, right? It would just, I think, how would it look? Well, it would go 8 pi over 4, 2 pi, so I think it would go like this. Right, it would take even longer to open. So these waves take longer and longer. The smaller and smaller this coefficient gets, as long as it stays above 0, and they turn faster and faster as this coefficient goes above 1. So could we do the reverse? Could we look at a graph and then from that figure out what the equation is? Sure, we could. And what we could do, let's just go over one example before we finish up in this video. If I had my y-axis and my x-axis, and we're looking at a function, well, if they give us a picture where it starts off at 0, right, and then let's say it goes up to 2, just like we did, and down to -2, so that's our amplitude. And let me just draw those guiding lines in for myself. That's one amplitude and the other. This should be right on 2. I'm just missing it by a little bit. So the sine function, let's say it went, here is pi, and then here is 2 pi, and here is 3 pi. Let's go all the way to 4 pi, a nice round number. So if we go all the way up to 4 pi, could we tell what's going on? Yes, we could. Or 3 pi we could as well, but anyway, let's go to 4 pi. One more dot, one more dash. So what would this look like? Well, if we saw a picture that goes up and then like this and comes down and goes to here, we know that the period is going from 0 over to 2 pi, and we know that the amplitude is going up and down to 2, so I know the function would be 2 for the amplitude, and the sine, well, I want to know what my coefficient is. So to find that out, I take 2 pi over the period equals the coefficient. So what's the period? How do you figure that out? You look at the wave and see where it's about to repeat itself again. So here, if I went from here, right, you can see the wave starting to happen again. That's my drawing, sorry. And oops, it shouldn't look like that. It would come up and then curve down to 3 pi and keep going. So you can see that at this point, at 2 pi, the wave starts over again. So that means that's the period. So it's 2 pi over our period, 2 pi, and and that gives us our coefficient of 1. So in this case, we have 2 times the sine of 1x, or 2 times the sine of x. Now that's it. I think I actually initially said that this would be repeating up to 4 pi. If that were the case, we could draw a wave that comes up and then comes down at 2 pi, and then will come back up at 4 pi. And you could look at that period, and you would get 2 pi over the period of 4 pi, where it repeats, which is equal to, well, what's that equal to? 1/2. And that equation would be 2 sine of 1/2 x. So you see that this formula right here for sine or cosine would give you the coefficient. And to deal with cosine, I mean, the only difference is, and we're not going to look at shifted videos here, but if you saw a point that's not at 0, either at 1 or 2 or something, it's not starting at 0, and then what it's going to be doing is coming down and up, that's the cosine function. So you have to really look at that first point to figure out what your function is.